we are Group 8 and I'm Karla Veronica R. Sevilla.
And I'm Jannie Mae Villareal.
I'm Christian Gaba, and our design of experiment is the Labyrinth. The Labyrinth is a video game that was created using low-level programming language, the assembly language.
It was successfully developed using different service functions. This includes int21h, int33h, and int10h.
The main goal of this game is to control the ball and to avoid the traps in the path towards the destination.
Assembly language is a type of a low-level programming language that was made for certain type of processor. It was used to register the binary code into a computer easier. As part of a programming advancement, assembly language is very important because some of the video games were developed using assembly language. The Labyrinth is a video game that was created using assembly language. It is a classic game wherein the player controls the ball, however there are some traps to be avoided while attempting to reach the destination. The game will display first the main menu, wherein it also explains what the functions of the different components are. Under the main menu is the high scores, which will show the record of the shortest period of time to finish the game. With the knowledge on video, mouse, and keyboard BIOS service, the Labyrinth was developed. As the technology evolves, people today usually use their smartphones or tablet to play some games which are mostly created using high-level programming languages. So people are not familiar that low-level programming languages can be used to develop a game. Hence, the group decided to create a game that uses assembly language, but it would still also be an interesting game just like some application people play on their phones. At the end of this experiment, the students should be able to apply the topics learned in the laboratory experiments, understand and utilize the different bioservice to develop a game, demonstrate how this bioservice worked as part of the program, and design a labyrinth game. This project is based on a classic game, Labyrinth. Labyrinth is a game of physical skill consisting of a box with a maze on top with holes and a steel marble. The object of the game is to try to tilt the playfield to guide the marble to the end of the maze without letting it fall into any of the holes. The game was developed by Villareal in Sweden and first released there in 1946. As years passed by, this game continued to develop and adopted by technology. In today's generation, there are a lot of applications that adopted this and made it mobile game for both Android and Apple phone. The most famous version of this game in Android is named Labyrinth, developed by Illusion Labs with rating of 4.6 star.
So here is the source code for the Labyrinth. So we start for the data segment in which we initialize the variables for main menu, in-game text, win or game over message, also for high score, circle, array circle, and the coordinates of the circle. Also for block, border, file handling, and timer. Next is the code segment, which start with begin procedure. Here we have move AX13H in 10H, which is for the set video mode and set color graphics. So next is the move AX0 in 33H, which is for the initializing of the mouse. So we call create underscore BG, which is for the creating of the background. So we have here move border underscore counter underscore 1 and underscore 3, which is for the X coordinate of the inner and outer border. Next, we have border underscore counter underscore 2 and underscore 4, which is for the Y coordinates of the inner and outer border. Going back in the begin procedure, we have call mouse underscore main underscore menu, which will be explained later. Next is the create underscore outer underscore border procedure. Here, it will output the outer border, which will have move AH0CH, move AL03H, in which it writes the graphics pixel at its coordinate. Move AL03H is for the color attribute, which is the cyan color. So here is the output for that procedure. Next is the create underscore inner underscore border procedure. This is same with the outer border. The only difference is the color attribute. In this procedure, we have move AL08H, which is for the dark gray color. Here is the output for that procedure. Next is the for underscore menu procedure. Here, it will display the start, high scores, and exit menu, and the elements of the game. And here is the output for that. Next is the box underscore main underscore menu procedure. So we have here get underscore black 1. It will output the black box, and the get underscore black 2 is for the green black. So here is the output for that. Next is the create underscore green underscore circle procedure, in which will display the green circle. It has 12 loops, and here is the output for each loop. So here we have create underscore black procedure. So here we have gray black, which have move AL07H for the color attribute. Next is the trap black, which is the same for the gray one, but the only difference is the move AL00H, which is for the color attribute for black. Next is the destination block procedure. Same with the trap block. The only difference is that the move AL02H for the color attribute for the green color.
Hi, I'm Christian Gaba, and I'll explain to you how this game works, how the ball moves, the win and game over conditions. But first, we will start with the mouse main menu procedure. The mouse menu procedure is for the main menu. It checks where the left button is pressed on the said coordinates. Move AX1 interrupt 33H shows the mouse cursor. For check 1, move AX5 interrupt 33H, it gets the mouse button press information. If BX is 0, then left button is pressed. If BX is 1, the right button is pressed. Shift right CX1. Shift right instruction. The CX is shifted to the right, which is the same as CX divided by 2. Then BTBX0. This means bit test base register. So it will check if the left mouse button is pressed, and JNC check 1 is jump if the carry flag is set to 0. So the next lines will be the coordinates of our text. So for the first one, this is the coordinates for the start button. So for the start text, this call for the for level 1 procedure and create clear screen, which will be discussed later. So for check 2, this is the coordinates of the 4 high score procedure, and also it will call the create clear screen. For check 3, the coordinates of the exit. And this is how we made the mouse main procedure. So this is the mouse menu procedure. So this is the coordinates of the start text. This is for check 1. This is the coordinates for check 2 for high score. And lastly, for exit, this is the coordinates for check 3. The next is the clear screen procedure. So the clear screen procedure clears the screen. Move AH0CH, interrupt 10H, writes graphics pixel at the coordinates. The coordinates are CX and DX, which CX is the column and DX is the row. And move AL00H is the color attribute, and 00H is black. So first is we move counter register and data register to 0, which means it will start at the upper leftmost window. This clear screen is a loop. It will increment the column until 320 x coordinate, and it will jump if it is not equal. So this is it. Jump not equal clear screen. And again, we move CX to 0. It will start again to the top leftmost window. But this time, the data register is incremented until 200. And it will also jump until it is not equal to clear screen. And this is our clear screen procedure. The next one is the for high score procedure. The for high score procedure writes the text for the high scores, and it saves the, no, it doesn't save, but it displays the high score text and the player name, the number, and the time. So the first one is for the high score text one. So we implemented the move AH 13H interrupt 10H for this. The move AH 13H writes the string. The AL, we move AL to 0, move BH to 0, and move BL 0FH. So 0FH is white color. And Leia BP H text 1 is the pointer to string H text 1. And move CX H text 1 length is the length of the string. And move DX 010H is the coordinate where DH is row and DL is column. So for the next one is for H text 2, H text 3, and H text 4. And before this procedure ends, we call the mouse high score procedure. And this is how it looks like. This is the number, the position for number, the player name, and the time, and of course the score. So this is the mouse underscore high score procedure. So this includes creating a file, opening a file, reading a file, and of course, it also includes how the timer will get stored to the data. So the mouse high score procedure, we implemented the file operation. So first is we hide the mouse by using move AX2 interrupt 33H, and we open a file using move AH3DH, Leia DX file name. So this DX is the pointer to the file name. The file name is hcore.txt. AL is the access mode. AL is equals to 2, it means the access mode is read or write. So the next is we created a file. Move AH3CH creates a file. CX is the the file attribute, so we clear the the counter register using the XOR. So move DX offset file name. And the next one is we read the file. So by using move AH3FH, it reads the file. BX is the file handler. CX is the length. It's the length. So move 500 to count register means it will read 500 bytes. Leia DX org str points to the buffer org str. Interrupt 21H. Then we move the file handler to the size num, and we clear the direction flag. So we also move 31H to num check. 31H is in hexadecimal, so it will read 1 as a decimal. And 30H to num check, 30H is 0 in decimal. We also included terminator. Move AL slash, so this is our terminator. Once the buffer is equals to the terminator or the slash, it will get the name. So to get the name, we incremented SI, source index, and it will move to the next character. And move AL to move space to AL. So it means it will compare the space to SI and jump if not equal get name. So until it is not equal, it will get the name. So the next one is for the timer. So move VX0. So this is the 0 here. And move AL SI plus 1. Move minutes number AL. So we move the AL to minutes number. So this is the tenths. And for the next one, BX plus 1. So means this is 0 plus 1. This is 1. So this is the ones for the minutes. And for the second, seconds underscore num BX0. So this is the tenths. And seconds underscore num BX plus 1 is the tenths. So next is we clear the base register. So for the next column, we move 0 to H2 column to move the column. So move AH13H, interrupt 10H is used to write the string. And check is the number. So for the next one, we incremented the column so we add column 0AH. So we incremented the column for the name underscore check. So name underscore check, the length is 1. As you can see, we move 1 to count register. So the count register for move AH13H is the length of the string. So add column 0AH, so this is like a tab key. Lay a BP name, so it will point to name 1 with the length of C1 underscore name. So add column 0DH, again like a tab key. Lay a BP min underscore num, it will display the tenths, and the next one is minutes underscore num 1, so this will display the ones, and min 1 will display the minutes text with, of course, for characters. So for the next one is for the seconds. So we add column 4 for the next column. Seconds underscore num 0 is the tenths, and sec underscore num 1 is the ones, and sec 1 is the seconds text. So the following will display or will show you how it moved the text and how the number player or the times for the next player. So this is the for level 1 procedure. So if you press the start button, it will call the for level procedure. So first is we hide the mouse by move AH to interrupt 33H. And we move 1 to game what level data. So this indicates that you are currently at level 1, and move 1 to checker input. So this checks whether you truly are in level 1. So we call for in-game text. So I will explain later what are the in-game texts. So first is move AH13H. So we want to display the level 1 text from this position. I will show you the position later. And of course, we created a new border. So we created a new border because only what's inside the border is being cleared, and this will also let us have space for the in-game text. And so this is the position or the coordinates. So move circle X, this is the column of the circle, and move circle Y is the row or the Y coordinates. So I will show you the position later. So the next will be the position for the blocks. So these are blocks X and Y. Blocks X is the column and blocks Y is the row. And then we call create block procedure. So this is a series of blocks, and I will show you what it looks like in the game. And of course, we also created a trap block and destination blocks. So the block X and block Y is the same for the destination block and trap block and create block. So before this procedure ends, we call the keyboard mouse checker, which will be discussed later. This is what level 1 looks like. So these are the series of blocks. These are trap blocks, and this is the position of the circle, and this is the position of the destination block. So these are the in-game text, the timer, and the main menu. So if you press enter, it will go to the main menu. So level 1 text was shown and was displayed for level 1 procedure. And this is what level 2 looks like. So this time we move 2 to the game what level data and also the checker input. This is what level 3 looks like. As you can see, it is full of traps. And we move 3 to game what level and checker input. And for level 4, we move 4 to the game what level and checker input. And for level 5, this is what it looks like. And we move 5 for the game what level and checker input. So if you reach the destination, it will move to the next level. So it will increment the game what level. And after win, this is what happens after you cleared level 5. So you will enter your name with a maximum of 8 characters. And it will be recorded or will be written in the hscore.txt file. It includes the timer also. Keyboard mouse checker procedure. So the keyboard mouse checker procedure checks whether there is an input from the keyboard and also from the mouse. And also it creates the green circle. The position from the green circle, which is the circle X and circle Y, will be based from the levels of the game. So it is included from the 4 levels. So move AH0CH, it clears the keyboard buffer, and we call the timer. The timer will be explained later. And move AH11H, interrupt 16H is the it gets the keyboard status. So from the keyboard status, if zero flag is 0, then the key is pressed. And JZ check underscore again, jump if 0 is set to 1. So it will jump to 0. It will jump to check underscore again if the 0 flag is set to 1. And of course, we get the keyboard value move AH 10H. So it waits for a key press and it will call ball movements procedure, which will be discussed later. And the next is move AH 11H interrupt 16H, J and Z get underscore keyboard value. So if the jump, it will jump if the 0 flag is 0. So it will continue to jump to get underscore keyboard underscore value until there is a value from the 0 flag. So this is the keyboard mouse trigger procedure. So this is the timer procedure. So the timer procedure is for the timer, and this is how the timer in our program works. This uses move AH to CH, interrupt 21H to get the time. So it returns CH as the hour, CL as minutes, DH for seconds, and DL for hundreds. So in this case, we will be using DH and DL. So first is we compare the start time. So the start time data indicates whether our timer is on or off. So we move 1 to start time. If the 0 flag is not set, then it will skip. And we move the seconds to our seconds data. Then the next is we compare the seconds to the seconds. So this seconds one is the tenths from our seconds data. And it will compare to the seconds of ones. So this is the timer procedure for our program. So this is how the timer works, and I'll explain how it works. So it uses the service function move H to CH interrupt 21H. So this service function gets the time. So it returns CH as the hour, CL as minutes, DH for seconds, and DL for hundreds. So first is we compared the start time to 1. So the start time data tells us whether the timer is on or off. So if the 0 flag is not set, then it will skip. Then we move the DH, the seconds, to our seconds data. So this is our seconds 1. And we move 1 to start time, which indicates the start time is on. So first is we compare the DH to seconds 1. So we compare DH to this. This is our seconds 1. And if the 0 flag is not set, then it will go to go 1. So go 1, it compares the minutes 0 to 39H. So it compares this to 9 decimal. Then if the 0 flag is set, then it will display using the move AH 13H interrupt 10H. So going back, we compared second 1 to 39H. So we compared this to 9. If the 0 flag is set, then equal to. So the equals to is here. This is equal to. Then we compared second 0 to 35, which we compared this to 5 decimal, and if the 0 flag is set, then it will check 2. So check 2 increments the pointer second 0. So it will increment. So from 0 to 1, for example. And next is it compares minute 1 to 39H. So it compares 9 to this minute. This is our minute 1. And if the 0 flag is not set, then it will go to time 2. So time 2 will increment the byte pointer minute 0. So it will increment this. And it will move 0 to this one. So this is our minute 1. Then we increment the pointer. We increment the byte pointer minute 1. So we increment this. So basically what happens here is when this one reaches 9, it will go back to 0 and it will increment this one. And if this reaches 6, or if this reaches 5 and this is 9, so it means that is the end of the second. So it will increment this one. This is the our minute 0, and if this reach 9, then it will increment this. This is the ball movement procedure. This is how the ball moves. So before this, we use the keyboard mouse checker procedure, and from there we use the service function move AH10 interrupt 16H to wait for the key press. So for example, from there we pressed A, then it will return the value to AL, or it will store the value in AL. So this time we compare the AL register to lowercase a. So if the lowercase a is pressed, then it will move left. Jump if equal, move left. And compare AH for BH. For BH is the left arrow key. It will also move left. And the next is compare ALD. So compare AH for DH is the right arrow key. And if we press D and right arrow key, it will move right. And compare ALW, jump if equal, move up. W is for move up. And compare AH 48H. 48H is the up arrow key, and it will also move up if those keys are pressed. Compare ALS and compare AH50H, which is the down arrow key. So if those keys are pressed, then it will move down. Also, if you press enter, compare AH1CH, then it will go back to the main game. So from move left, to make this happen, we need the position of the circle. So we use move AH0DH and interrupt 10H. So this will read the graphics fixed cell at the coordinates. We move the column of the circle CX and subtracted 10 to it, and row of the circle to DX and added 5 to it. And if the left side fixed pixel of the circle comes contact with the pixel of the color 07H, which is the dark gray, or the color of our black, then it will exit. This jump exit. Then we call create dark gray pixel right side. So this will be explained later. We subtract circle X to 01, so which means to the left. But the concept is when the ball moves to the left, the pixels will go to the left and the gray pixels will be on the right. So gray pixels will remain from the right, which will make it look like that it moved to the left. Then call detect hit, which will also be explained later. Move right also has the same concept, but this time we add 6 to the column of the circle and 5 to the row of the circle. Also, we have used the collision detector, compare AL07H, and also we call the create dark gray pixel left side. So this time it will create dark gray pixel from the left side and add circle X01, which indicates the circle moved to the right. So the same concept applies to move up and down, but this time we will subtract and add from the data register because the data register is the row. So for up, we subtracted 1 from DX, and down we added 15 to DX. So the collision detection is also the same. When the top pixel of the circle comes in contact with the block, then it will exit. And if the bottom pixel of the circle comes in contact with the block, then it will also exit. And that is how the ball moves, and the secret to it is the create dark pixels from the sides. So this is the create dark gray pixel. So what it does, it creates dark gray pixels from the sides of the circle. So first, we will discuss the create dark gray pixel top. So this will create dark gray pixels from the top of the circle. So we use the move AH 0CH interrupt 10H. So it write graphics pixel at coordinate. Move AL 08H means it is the color attribute. 08 is dark gray, and CX is the column and DX is the row. So we duplicate the CX, we move the position of the circle X to CX, and to erase circle X and erase circle X dupe, which will be used in erasing the previous parts of the circle. So move CX5, we use this for this loop. So the top edge loop. We move erase circle X duplicate to CX interrupt 10H, so it will activate the function, the service function, and it will decrease erase circle X dupe. So it's hard to explain. No, no. So this is the top edge of the circle, and the next one we move erase circle X to CX and add CX to 02. So this is hard to explain, and I will just show you how it works. So this part, so decrement CX interrupt 10H sub CX by 6 and interrupt 10H and decrease CX interrupt 10H. So this is how it looks like. This is what it looks like. And from the second part, move CX erase circle X, add CX03, increase DX, interrupt 10H, sub CX10, interrupt 10H. So this is what it looks like. So that is the part that is being erased. So it will create dark gray pixels from those sides. So the next is move erase circle X to CX, add CX04 to the next. Increment DX, interrupt 10H, increment DX, interrupt 10H, sub CX12, and decrement DX, interrupt 10H, increment DX, interrupt 10H. So this is what it looks like, those parts. And from the next is, from the last one, add CX05, increment DX, interrupt 10H, sub CX14, interrupt 10H. This is what it looks like. So for the second part, create dark gray pixel bottom. So the same concept is applied, but now we will create dark gray pixel from the bottom. So I will just show you how it works. So first is we add DX14. So this is the bottom side of the circle. So the bottom edge is this part. That is the bottom edge of the circle. So the next is this one, and this decrement CX interrupt 10H sub CX06 interrupt 10H. Decrement CX interrupt 10H is this part. That is the part, that is the bottom part of the circle. So next one is the move CX erase circle X, add CX03, which means the next side. Decrement DX interrupt 10H sub CX10, which will go down, interrupt 10H. So this is that part. So move CX erase circle X, add CX is equals to 4. So this is that part. Decrement DX interrupt 10H, decrement DX interrupt 10H, sub CX12 will go down. So this is the sub DX CX12. Increment DX interrupt 10H, decrement DX interrupt 10H. So for the next part, that is that part. So last one is this part. Move CX erase circle X, add CX05 is 1. decrement dx sub cx equals to 14, this one, interrupt 10h. So for the next part is the create dark gray pixel right. Same concept is applied, but now the dark gray pixel is created from the right side of the circle. So this is the right side edge of the circle at dx5, which means the right side. This is the right side. So this part, sub dx2. So this is that part, that one. Sub dx equals to 2, decrement cx, interrupt 10h, increment dx, interrupt 10h, add dx equals, add dx6, this is it. Interrupt 10h, increment dx, interrupt 10h. So the next part is this one, move dx, erase circle y. Sub dx equals to 3, this one. Decrement cx, interrupt 10h, add dx10, this is that dx10, interrupt 10h. And next one is this one. Move dx, erase circle y, sub dx5, the sub dx5, decrement cx, add dx14. Last one is the create dark gray pixel left procedure. So same concept, but from the left side of the circle. So this is the left side. So to get here, we sub cx by 9 and add dx by 5. So the next part is this one, sub dx2. So this is a sub dx2, increment cx, interrupt 10h, increment dx, add dx06, this is add dx06, interrupt 10h, increment dx, interrupt 10h. Move dx, erase circle y, this one. Sub dx03, this one, add dx10. Next one, this is add dx12. No, this is sub dx4, add dx12. And last one is sub dx5 and add dx14. So that is how we were able to erase the sides of the circle when it is moving. So the next one is the detect hit procedure. So detect hit is for the win, game over, and repeat game level. So first is compare AL03H, compare if the left circle hits the background pixel, then game over. Compare AL00H, if the ball hits the trap, then it's also game over. Compare AL02H, so if the ball comes in contact with the destination block, then it will check the level. So check the level increments the game what level. So for the game over, so basically what it does, it displays the string using move H, 13H, and interrupt 10H. With color, of course, red. So jump repeat game level. So if you get a game over, then you will repeat the game. So it will compare so for example, you are at level 1 and you got a game over, then it will compare the game at level 01, then it will jump if equal, it will jump to go level 1 if the game level is equal to 1. The same concept applies until game level 5, go level 5. So after game level 5 is the win length string, move H, 13H, and interrupt 10H. And after that, we call the delay game, create game screen, getting time, and for high score. This is the go level 1. So for go level 1, so jump if equal go level 1. So it will call the delay game and it will call for level 1. So for level 1 is the procedure for the level. For the level 1, this is for the level 2, level 3, level 4, and level 5. So to better understand this, we will have a demonstration of the game, and that will be the end of it.